Okay, mostly this week we'll cover the Unit 2. We'll talk through it and then we'll try some of it in the playground. Let me minimize the browser here. And I guess we could start with a playground file. I don't know where I'm saving my stuff at here. I guess I can't make it any smaller than that. Again, Unit 2 mostly goes over the basic building blocks of any app that you would make inside of Swift. And some of the basic building blocks, again, are the ones that are listed here. Okay? And so the first one they go over, of course, is strings. So when we talked about strings, it's basically mostly text that you would use, but you could also have numbers as strings, especially if you put a quote around it, then Swift is going to see a number as a string, or basically letters or numbers that are not an integer, right? How to declare a string, you've already seen how to do that. Of course, you can have a consonant like a let, and of course strings have the quotes around them. We already learned that already. If you assign a string to a consonant using let, the string is enumerable and can't be modified. By assigning a string to a variable, you're allowed the string to change. And we already know that. And again, you probably saw in the lab about the multiple lines of code using the quote marks here. If your string literally needs to be multiple lines, simply surround your set of characters with 3 double quotation marks. In this multi-line form, the string literally includes all the lines between the opening and closing quotes. The string begins on the first line, and after the opening quote ends on the line before the closing quote. So again, you'll see you have 3 quotes here, you have 3 quotes here, and if you print joke, which is a consonant here, you would then get this line of code here. Okay, so you can see that there. They also talked about white space in your lab, is correct? Do you remember that? Okay. The white space before the closing quote tells Swift that white space to ignore before all the other lines, even though both lines of your string literally include white space at the beginning. That indication was stripped off when you printed your string literally, since the final 3 double quotes marks were identified equally as far. Okay, so we talk a little bit about white space. If the string will include double quotes, you'll need to use the backslash, known in Swift as the escape character. That's because you're escaping the string. So then they have a greeting there. Let greeting equal is a tradition in programming to print hello world. You can use the escape characters with other letters and symbols to produce specific results. Of course, you got the double quote, single quote, backslash, tab, carriage return. Remember, you've seen this before when you were printing a string inside of your playground, right? And you were wondering what that crazy /R was at the end of your at the end of the print, right? That was the return key. You often find that you want to start with an empty string, then add it to it over time. This means you'll need to make up a variable, then using the following syntax to initialize the string without any text. Again, it's an empty quote. If you need to check if a Swift string is empty, you can use the Boolean property. We looked at the Boolean property, I think, is empty. Let's see. You might expect individual characters are a type character, but since strings are much more common in programming than individual characters, Swift always infers the type of collection of characters, even a single character, as a string, unless you specify otherwise with a type of annotation. So it sees characters as a B in this case. Let B equal character B. I think that character option has been deprecated or gone. So I know they're using it here, but once you get to doing the there's a lesson where they're using character that's not working properly, and they said, oh, we got rid of character, and I don't know what to use in its case yet. Again, they were combining strings together. You saw that in your lab, right? Do you remember doing that in the lab part? Putting strings together with a plus. If the existing string is a variable, you can use the plus equal to operator to add or modify it, to change it. You already saw that in the lab. Let's see, you can insert the raw value of a constant or variable into a string by preceding the name with a backslash and wrapping the name in a parentheses. In the example below, the print string will contain the raw value of the name and age consonant. You saw how to do that again in the lab as well, if you remember doing that, putting together the name. So multiple constants. Again, the forward slash and of course the round brackets on both sides. It's quite easy to do. You can place an entire expression within the parentheses. These expressions will always be evaluated first before being printed or stored. Again, you can combine them together, is what they're talking about here. Using string interpolation, the raw values, the A and B consonants are inserted into the printed string value. Developers often need to compare string values to see if they're equal to each other, just as you do with numbers. You can check for equality between two strings using the equal to operator. Remember the two equal signs, right? This means two things are equal to each other. So again, you see let month equal January, let other month equal January. Are they equal to each other? Oh, that one is not. If month is other month, then print they are the same. If lowercase, they are not the same. Remember that you know the lowercase j here for January is different than the uppercase j. Remember, strings are what am I trying to say? Caps. But maybe you want to ignore the capitalization of a string when checking for a string's equality. You can use the lowercase method to normalize the two comparing. And again, there is a way to avoid that. And so look at that. I guess it lowercase is everything. See that? Lowercase everything. Lowercase everything. If you want to match the beginning or ending of a string, you can use the has prefix with the you know the lower. So they talk about that, and of course you did all those. At least most of this in the lab. Maybe you want to check if one string is somewhere within another string. You can use the contains method to return a Boolean value that indicates whether or not the substring was found. So again, finding something in a string. The count method, of course, is one that's quite popular. It's the size of any collection can be determined using the count property. You can use this property to compare strings or evaluate whether strings meet a certain requirement. So again, they're using the example from a password, right? Your password's too short. You want 8 characters in your password. Basically, count. It does what it says. It counts up, you know, how many are in a certain list, or in this case, not a list, but I'm in a string. Count is popular. In this last year, you learned that you can use the switch statement to perform specific blocks of code based on a particular case. You can use the switch statement to pattern match multiple values of a string or characters and to respond accordingly. Let some characters equal E, switch some characters, case A, E, I, O, U, Print some characters is a vowel. Print some characters is not a vowel. E is a vowel. So what they're doing is comparing, okay, using the switch statement. Switch then compares what is some character, and then the case is it's going to compare between each. A, E, I, O, U is a vowel. Okay, this is a vowel. And then default is if none of these are met, then it is not a vowel. Of course, this meets this, so this is printed. Does that make sense? Again, the lowercase, it turns everything lowercase. Has prefix, has suffix, and contains. Index before, index after. So there's a whole bunch of options here. Whoosh. Every Swift string adheres to an international computing standard called the Unicode. Unicode compliance allows Swift to go beyond the short list of letters and symbols in the English writing. Instead, Unicode encompasses over 128,000 different characters across multiple languages. This includes the accent on characters, emojis, symbols, kanji, and other special characters. Unicode ensures that the length of these characters are rational so that E, and the, what is that, a cow emoji, each have the correct length of 1. In addition, Unicode supports text that reads right to left as well, left to right. So, again, your emojis are built into the Unicode. And of course, Resume has accents, and of course, you can have the infinity character. Okay, let's do the test. Find out how we discussed. When you declare a string, how do you set the initial value? With the Unicode, with a string literal, with the operator plus equals, with an index. What do you guys say? B? Yes? Okay. Making sure you're staying awake here. To compare two strings, how would you check for equality? A. Moving along pretty good today here. Given the following code, what is the result type of OX? OX. Okay, so of course, O is a character of O. I guess it's an uppercase O and a lowercase, and X is a character of X. Let OX equal string 0 string X. So which one would you say? Character, string, or OX? OX. Which one? C. C is a string. There you go. Given the following code, what is the result value of math expressions? Let B equal 5. Let M equal 3. Of course, 3 is a string there because it's covered around with quotes. Let X equal 5. But you can still use the number in 3, though, right? Let math expressions solve for X. 20 equals MX plus B. Solve for X 20 equals 3X plus 5. Which one? A? A. Okay. Very good. Last one. Why does the following expression return false? Well, Jonathan is lowercase j, and Jonathan, the big one, is uppercase j, right? Unless you put the lowercase in front of those, and then it would work, right? Remember the lowercase? There you go. Okay. You did beautiful. Okay, ready to move on? Okay, let's talk about functions. So again, the lab will give you a lot of information about how to combine strings. Just practice that. I think would be a very good use of practicing. Today, also, we'll be looking at text inside of Xcode and putting text in. In previous lessons, you learned to use existing functions such as print to perform a task. In those cases, you didn't have to worry about the details how the function was implemented. It just worked. But if you want to write maintainable, reusable code, you'll need to be able to create your own functions. In this lesson, you'll learn how to declare functions with different parameters and return types while gaining a better understanding of the importance of abstractions. Again, in this case, the function is a way to kind of group your code together into a word, the function. When someone gives you the task, get dressed, it seems like such a simple operation. Oh, well, we don't have to read all this, but if you want to. But the details of what you wear, you'll put your clothes on, and where you'll get the clothes from are all wrapped up in the get dressed phrase. The idea of taking something that is complex and defining a simpler way to infer it is an abstraction, and the function is one of the fundamental ways to create an abstraction in code. A function is made up of three things. Its name, in this case, name, an optional list of parameters, and a return value, an optional return type. Calling a function is similar to making a phone call. You pass information along parameters, but you can also get information back, return values. A function in Swift can take 0, 1, or multiple parameters, but can also return 0, 1, or multiple values. When a function does return a value, you have the option to ignore it. Similar to declaration of a constant with let or a variable with vary, func keyword tells Swift compiler that you're declaring a function. Immediately following the func, you add the name of the function followed by parentheses, which you may not include the list of parameters within them. Finally, if the function has return value, you write an arrow, that's a minus chevron there, followed by a type of data the function will return, such as an integer, string, or a person, so on. So again, they have an example of how to make your own function here. You start with a func word, and then of course the function name, and then you have parameters that are in the round brackets, and then you return the value of, whatever this does here is going to return something here. So maybe you have something in here that's doing something, and then what is the result there? And notice you have the round brackets, which is the body of the function. Think about your daily routine. You probably identify plenty of repetitive tasks you perform each day, such as tying your shoes, making breakfast, driving to work or school. Some of these tasks require no additional input. You tie your shoes the same way every time. For functions without inputs, there'll be no functional parameters. Tie my shoes. However, each breakfast may have a list of ingredients, so you need the parameters to specify the list when you're calling the function. Make breakfast, you'll see you got food. Okay, and so you would use this word is for eggs and orange juice together in a list. These list is combined with the these square brackets. Or these are, what are these called, brackets? Here's an example of a function that would display the first 10 digits of pi. Since printing pi requires an addition input, there's no parameters. And since printing pi doesn't need a return anything relevant to the function caller, no return value is specified. So again, this is the name. There's no value in here. And the reason why there's no value is that it knows what this is already.
Question.
Uh-huh.
At the top there where it says make breakfast.
Uh-huh.
Does the food part.
Uh-huh.
Are they specifying food as like a list?
Yes. Uh-huh. So you can have more than one in here. Is what it comes. You can put another one over here. So you have food, eggs, orange juice, then you can put another one over here, lunch.
Okay.
With a colon. You can put a lunch with a colon in there. With more round bracket, with square brackets as well. So you can actually list multiple things in there. So this could be breakfast. Well, make breakfast.
So it's just kind of interesting that they seem to be defining the list at the end of
yeah.
Right there, instead of just defining the list separately and then just putting it into the parameter. You know what I mean?
Yeah, I understand what you're saying. Mm-hmm.
Oh, you could pass the parameter too.
Yeah, I think normally you would write let food equal or and you would just put it into make breakfast food and then just close brackets.
True, but here they are passing it directly. So
Yeah, so they're both
declaring it.
I guess they're both declaring it in.
Right.
So let's talk about the parameters on it. Just specify a function with a parameter. Insert a name for the value in a colon and then the value type, all inside the parentheses. For example, say you wanted to write a function called triple that takes an integer, triples the value, and then prints it. So they have a function. Of course, the name is called triple. The value is going to be an integer. Let is defining what result is, equals the value, whatever that is, times 3. Print, if you multiple value by 3, you'll get the results. Okay, so then you can add something to value later. Triple value is 10. See how we put 10 into value here, right? And if you multiply 10 by 3, you'll get 30. So again, in this case, you're defining value as an integer, okay, and the result is a value times 3. So we need to give value a value, and then in this case, they gave the value 10. So triple is the name of the function, right? To pass multiple arguments to a function, you need to separate each parameter with a comma. The following is an example of a function that takes two integer parameters, multiplies them together, and prints the result. Again, like I was telling you before, you can list these together in one, so you have a comma between that. So you have first number is an integer, second number is an integer. That results equals first number times second number, print the results. And then, of course, you can give each one a value. First number, you can say, hey, first number be 10, let second number be 5. And then print the results is going to give you 50. Does that make sense? Okay, that's just a way of organizing the data here. Again, you could have wrote it a number of other ways as well. So far, the label for each argument within the function has the same name literally as it does externally. Consider the following example. The first name is used both within the function and when the function is called. Say hello, again, is a string. First name is a string. Say print hello, and then the first name. Say hello, first name is Aldine. But imagine you want the function to read a little more clearly. Say hello to Miles and Riley. The argument labeled to and makes the function read very clearly. Say hello to Luke and Dave. However, check out the implementation of this function. Print hello to and. So they have the to here, and then the and here. You can probably see that within the body of the function, to and are very poor names. If you want the name of a constant within the function to differ from the argument label, you can specify an external name before the local name. So they actually put the word in there. Another person. Print hello person and another person. Say hello to Miles and Riley. Print hello world. Okay, let's move on. To omit the arguments label, use the underscore in place of the external name. Okay. The function say hello, and then you have this in there for person and string, and the underscore here is another person string. Print hello person and another person. Say hello Luke and Dave. Parameters allow the function to remain flexible, but often there's a value you want to most of the time. For example, you might want to drink water with nearly all of your meals, but every now and then you have a glass of orange juice instead. So again, this is a way of changing. To omit the argument label, use the underscore. Okay, so you don't have to, like in the example before, they had, you know, the to and the and here, but you don't necessarily need the to and. You can put the / in there. As part of the function definition, you can provide a default value for any parameters. This way you can call the function with or without the parameters. If the parameter is unspecified, the function will simply use the default value. You'll need to place all parameters within the default value at the end of the list, and these parameters must all have argument labels. So again, in this one, you'll see that as part of the function definition, you can provide a default value for any parameters. This way you can tell the function with or without the parameters. If the parameter is unspecified, the function will simply use a default value. You'll need to place all parameters with the default values at the end of the list, and these parameters must have argument labels. Uh-huh.
This underscore, right? I didn't get that.
Yeah, again, I think what the whole point is that over here in this example, they're specifying
Name.
what 2 is, right? 2 is a string, and is a string, right?
Right.
Okay, but then you can add to person, right? Is a person, and is another person. So you have a person and another person. But you don't really need, this is a defined word, right? And is a defined word. 2 is the defined word, but you can also specify them with no value at all. And that's what the underscore is. Hey, this can have no value at all at the beginning, and we can add it later, I guess is what I'm assuming.
But why do you need that? Because person is the variable, right? You're not really using 2 or and there.
Because it'll give you an error message, that's why. It needs some kind of value there. I've seen it a million times. Remember when you come up with an argument and it says fix, right? When there's an error?
Right.
And you hit the fix button, it just puts it puts the underscore in there. And the reason why is because it's missing a value there. It needs something there. It's very common.
So is it sort of like a placeholder?
Yes.
Okay.
It's just that it needs a value there.
Okay.
So I guess, you have the 2 here is a string, and is a string. Hello, 2, and there. And then again, this is going to be a string, but it needs a holding spot there for some reason.
So in this case, though, they have, in this example, they don't have, oh, they have 2, yeah.
Yeah, there's a 2. I think once you start seeing it adding the / at the beginning, to omit the argument label, use a /. Okay, so there's a, the label for this argument is what they're talking about, right? Okay, coming up with return values. Part of the function definition you can provide. Oh, this is what I was reading before, the default value. Let's try and figure this one out. Function display. Team name is a string. The score is an integer equal to 0. Print the team name, colon, and the score. So we don't know what score is in this case. Display team name Wombats. So that puts Wombats into team names. And then score is equal to 100. Display team name Wombats is 0. It's unlikely that you want to print the results is before the results from multiplying. Instead, it might make more sense if the function simply returns the new value. So to do so, you'll need to adjust the function declaration to have a return value and specify the value type. You've learned that multiplying 2 integer types will always result in an integer, so that the return type you'll use. Multiply first number is an integer, second number integer, return an integer. While the function body, you'll use the return keyword to specify that a return function will return. In this example, you want to return results. Function multiply first number is an integer, of course, second number is an integer, and then of course this is what is returning the value. It's going to give you this, and then within there you can let the results be the first number times the second number, and then print results. Rather than multiplying the value, storing the new value in results, and immediately returning it, the function could also be written without the consonants. Again, putting these two together right here instead of doing the equal here, right? Just a shorter way of getting the result. Okay, you're going to return this. It'll give you a result.
Question. So is this like if you were to call the function somewhere else and you would already have a
Yes.
parameter in mind that you want to name it? Yeah,
Yes, yes. This is where you would use it in a class or somewhere else, right? Or in
Yeah,
a
instead of specifically
mhm.
having it be
Yeah.
a result, you would want to maybe call it something else when
Yeah.
you call it up.
To call the function and use the return value, you can assign in the return value to a consonant right here, like you were just saying. So again, you're putting a 10 in the first number, a 5 in the second number. My results, it goes for print 10 times 5 is my result. You don't need to use my result ever again in the future. You could use the function inside the print statement and skip assigning the value to a consonant. Print 10 times 5 is multiply first 10 number second 5. So they're using these words is what they're saying.
I had a question.
Uh-huh.
Could you call, in that example, could you call multiply with just 10 comma 5?
Like it is here, you mean? Oh, no, you say comma?
Yeah, right there.
Uh-huh.
So instead of saying first number colon 10, second number colon 5,
Uh-huh.
could you just call multiply 10 comma 5? Because I think they're like Python.
Yeah, for that you have to do the underscore. Right?
Oh, is that what you
Yes.
do? Oh, so you still have to do that.
You would still have to put the underscore in there.
You can't just sort of send the values.
Yeah, I wouldn't know what it is.
Okay.
That's where the underscore would come in. Okay, let's read this quizzes, and then we'll get into building our app today. Okay, so again, our app, hopefully you have your graphics. I will show you how to bring the graphics in today. So we'll get to Xcode in a minute. Let's go through these questions. Which of the following statements are true about the function below? Function greeting name is a string. Print hello name. It can be called using greet JSON. The first parameter requires an argument label. The function returns a string. The function has no return value. So again, we have greet. Greet has a value of name, which is a string, right? Print hello name. Would that work?
In this case, no, because there's no underscore. So A is not true.
A? No.
A is not true.
B? The first parameter requires an argument label.
Right.
Yes. Why does the following function not compile? Function increments. There's your underscore. Value is an integer by the amount colon integer.
Oh, by is wrong.
By is bad.
Yeah,
Increment by is already function defined in Swift. This one? Dope. Second one?
and D actually, it's D.
Function parameters aren't separated by commas. Yes. A function can be called using the code below. How was the function declared? Let value equal multiply 5 by 4. A function can be called using the code below. How was the function declared?
C.
You would have to put the forward slash in there.
It's a C.
You would have to put the forward slash in there. Which one? C?
Yeah.
Yeah. Because 5 doesn't have anything, right? Which function returns two integers?
B.
B, I would imagine. It's integer, integer. Ooh, we got 3 out of 4. Not too bad.
That was wrong.
What's that?
The first one I think.
Yeah. Yeah. Okay, the structs we can do next class. Let's jump to the, I'm going to jump on up to the Swift stuff today. Let me stop this video.